All right, the full chapter 25 breakdown. Let's get right to it. I suppose the one thing I should also do is open up chapter 25 PowerPoint, which is going to require me to download it. Download it. Come on. Come on now. I'm hitting it. Come on. Easy. They made it so incredibly easy. Okay. So, one capacitor, we have voltage, and we have this thing F, capacitance. So, let's take this problem, and let's throw it into this little thing, software. And let's make it readable. There we go. And I'm thinking about blue. Nice shade of kind of blue. A very dark blue. But it'll have to do. I was thinking a little bit lighter. What if I slide the slider? That blue is pretty good. There we go. Okay. So the capacitance C going to be 22 times 10 to the negative, I want to say negative 9th farads, and then V is going to be 132 volts. And charge equals CV, so charge here is going to be 22 times 10 to the negative 9th times 132, which is going to equal 2.9 times 10 to the negative 6. Something seems wrong. Q equals CV, right? And Q, charge equals capacitance times potential difference. Should be right. Given that is that, mine's not close to that. Well, let's try it. 2.9 e to the negative 6. E to the negative 4? (22, 132) e to the negative 3rd. So what's micro? Times 10 to the negative 6th. Okay. Yep. Once we change this to times 10 to the negative 6, this becomes 0.0029, which is the same thing. So, right concept, a little bit different math. Let's move on to the next one. Oh. Two flat metal plates. This is going to be a parallel plate capacitor. And see, we have an area A equals 1.1 meters squared. And we have capacitance C equals 2.5 farad. And we're asked to find separation, or the distance. So going to our notes here on parallel plate, we're going to have C equals EA over, or epsilon 0 A over D. Now we've got these, we're trying to find this, so D is going to equal, this is just going to be epsilon 0 A over C. Are they just going to trade places? You multiply both sides by D, and then divide both sides by C. Yeah. So here it's going to be 8.85 times 10 to the negative 12, I think it's negative 12, times area, which is 1.1, divided by 2.5, and the distance is going to be 3.894 times 10 to the negative 12. Yep. And then could this capacitor be constructed? It would be no plate separation is less than the size of an atom. Okay, on to the next one. This one's always very fun. Okay. Now, what we can do is we can think of this side as one whole capacitor and this side as another, and we're going to want to label this as C3, C4, and then C5. And we're going to want to find the C equivalent of C23, C2, 3, 4, and then C2, 3, 4, and 5. And what we're going to notice is it's going to be the difference between parallel and series. Is C2, 3 appear to be in series. And if we go back to the notes here on how to add series versus add parallel, this would be what parallel looks like. And this is series, just like that. This is going to be 1 over C inverse. So C23 is going to be, let's see, each of these have a capacitance of 12. 1 over 12 plus 1 over 12 inverse. That's going to be the C equivalent of 2, 3. Now 2, 3, 4 is going to be C equivalent of 2, 3 in parallel instead of series. So this is going to be 1 over 12 plus 1 over 12 to the inverse plus 12. And then C234, this entire top part, could be thought of as one singular capacitor that is in series with this one. So this is going to be 1 over let's see, 1 over 12 plus 1 over 12 inverse plus 12 plus 1 over 12 inverse. And that should be the C equivalents for each of these. And now, I could just find them real quick. C23, C2, 3, 4, C2, 3, 4, 5. One over 12 plus 1 over 12 inverse is going to be 6 plus 12 is going to be 18. And then inverse of 1 over 18 plus 1 over 12 negative 1. It's going to be 36 divided by 5 is going to be 7.2. I don't like that. I don't like that it's less. But what can you do? It would be series. So all works out. It's all the same. So now what we say is we're going to start out here. This is going to be C1. This is going to be C2, 3, 4, 5. And there's going to be a charge from here, from V, which you might conceptually be able to tell that it's here, plus minus, but I don't think that's good. So we know that charge equals CV. And the voltage coming from here is 17. So C1 is going to be charge, which is 12 microfarads. So we'll have to fix that. In fact, let's just fix it here. So it's going to be 12 times 10 to the negative 6 times 17. This is going to be Q for C1. This is going to be 2.04 times 10 to the negative 4th. So now we actually have answer A. Okay. And then the C equivalent here is going to be 7.2 times 10 to the negative 6th times 17, because in parallel voltage stays the same, and in series I think it's charge stays the same. There's a YouTube video that goes over it, but I have it somewhere in these notes actually. Yep. Parallel equals V, series equals Q. So now that we know the voltage goes across, we can say the Q here is going to be 7.2 times 17. So Q here is going to be 1.22 times 10 to the negative 4th. And now we have C5. And then C4. Or C5 and then C2, 3, 4. And these are in series. And in series, the charge carries over. So the charge on both of these is 1.22. Is going to equal, we know the C equivalent here is 18 times 10 to the negative 6th. We don't know the voltage. So we divide both sides by 18. We're going to have 1.22 divided by 18 times 10 to the negative 6th. And this gives us a voltage of, I hate that. Oh my gosh, that is such a... 1.22 times 10 to the negative 4th divided by 18 times 10 to the negative 6th. Oh, that's much worse. Let's put parentheses around this. There we go. And here we're going to get voltage is equal to 6.77. And now we're going to have C23 and then C4. And the voltage carries over. So the voltage of 6.77 and the charge equivalent of 6 times 10 to the negative 4th is going to equal Q, which is 6 times 10 to the negative 4th times 6.77. Q equals 0.00406, I guess. Oh, I don't like how it says it's wrong. It can't be wrong. I did everything right. The answer has to be wrong. I mean, what they call the answer. Series, parallel, series. It's all good. Carry the voltage. Carry the voltage, carry the charge, carry the voltage. Series, parallel, series. Yeah. Looking good. Q. Divide this by that. Get the voltage. 5.5. 6. Yeah, everything's correct. 0.00406. Yep, everything's perfectly fine. 1.22 divided by, or times 10 to the negative fourth. (18 times 10 to the negative 6). That's the right voltage. What could it be looking for? I legitimately have to disagree. Yeah. And that plus 11, yeah. And then this plus. Yeah, that's exactly what it is. So this part's all good. Check. This part I know is good. Check. This part is the same as what I did here. Take this, divide them, and then here, C23 is 6. I mean, I can look. Yeah, it's 6. 6 times 10 to the negative. I called it negative fourth. To the negative sixth. Which it counted it. So that was my mistake. Negative sixth. There. I'm gonna pass on this one for right now. Okay. So we have two parallel plates. We have an area equals 150 centimeters squared, which we have to convert that to meters squared. Equal magnitudes and charges. Q 9.4 times 10 to the negative 7, but opposite signs. With, let's see, the electric field within the dielectric material filling the space between the plates. What, I don't know what the right symbol for electric field, but let's say 3.5 times 10 to the 6 BM. These are both in coulombs. Charge and C, charge and C. And then (150 centimeters squared) becomes 1.5 times 10 to the negative 2 meters squared. Now, let's see what we have in our notes for parallel plates. I think those are all up top. Work done. Calculate the dielectric constant K. Here we go. Didn't like that sound. Sounded like a wasp. Okay. So that's one way to find K. Is that all they had to say about K, or is there more up here? Parallel plate. Yeah, I guess so. I don't think we have Q and Q prime. Induced charge on the dielectric. Maybe we do have Q prime. Here we go. Q over epsilon 0 A over E. We don't know E, do we? Unless E is the electric field. So what we could say here is Q over epsilon 0 A over E equals K. Wouldn't this be the same as that? I'll leave it. So let's try it. We have a Q of 9.4 times 10 to the negative 7. Epsilon 0 is 8.85 times 10 to the negative 12. And the area here is 1.5 times 10 to the negative second. And then our E is 3.5 times 10 to the sixth. Where K equals 1.089. Oh boy. Wait, did I say 6.5? 3.5. Yep. Magnitude, the charge is induced. So it's gonna want to in coulombs. Magnitude. This Q prime? Yeah. So it's just gonna be Q 1 minus 1 over K. And again, Q here is 9.4 times 10 to the negative 7th. It's going to be times 1 minus 1 over 2.0231369338, which is 4.75. Times 10 to the negative 7th. Okay, a slab of copper with a thickness B. Let's just write B equals 2.3 millimeters. Area is going to be 2.45 centimeters squared. And the plate separation is 5.2 millimeters. So I would like if we convert all of these into proper units immediately. They want it in picofarads anyway, so this is going to be more converting. But let's see, what do we have in the notes that's similar? We have this weird thing for a Gaussian surface, but I don't think it's that. Is it going to be this AB B minus A nonsense? It's for a sphere. This is parallel plate nonsense. The distance here is going to be different. I think it's going to be something like epsilon 0A. So I'm thinking it's going to be, let's see what this is. C equals epsilon 0A D minus B. So let's see what this gives us. 8.85 times 10 to the negative 12 times the area, which is 2.45 centimeters squared. It's going to be times 10 to the negative 3rd, I believe. And then it's going to be 2.3, oh boy, millimeter to meter times 10 to the 4th, or would be 5.2 minus 2.3 times 10 to the 4th. Okay. .74, please. Okay. My units are way off. So I have to figure out what was so off, because I'm getting e to the negative 19th. Are these negative 4s? First off, I don't even know if it is 4 to begin with. Negative 4 helped a little bit. we'd have to do centimeters to meters squared, and then millimeters to meters. Oh boy, to make up that difference. Well, it's not worth trying to figure out right now. The math was right, the units were wrong. So now if charge Q is 3.4 microcoulombs, so Q equals 3.4 times 10 to the negative 6 coulomb is maintained on the plates. What is the ratio of energy stored before the slab is inserted? Let's see if anything in our notes here talks about Q equals E epsilon 0 A. What's it asking for? Ratio before and after? E equals Q epsilon 0 over A. Energy stored, is that going to be E? I mean, what would the Q be before? How would I find the ratio if I don't know the before? I only know the after. I think it'd be Q epsilon 0 over Q epsilon 0 with A. Here's energy stored right here. E squared over 2C. U over volume. Epsilon 0 E squared over 2. That's energy density. Energy stored. U equals Q delta V. Q squared over 2C. Total energy. We don't have any delta V. So that's energy stored in an electric field. I don't think this is an electric field. E0 over E, it's going to be this. Epsilon 0 is Q over epsilon 0, or energy in a field. Q epsilon 0 over A. We found the C. Right there. And that's total energy. How to find the before and after. E is going to be like the electric field, and the energy stored is going to be U, so it has to be U. Let's get total energy. Q delta V. We have no delta V, so we can't use this equation. C times V. It has to be Q over 2C. Q squared over 2C. But that would just give us the after, the total energy. Which I don't like this. 3.4 times 10 to the negative 6 over 2 times. What was our answer? 0.74. Getting 2.29 times 10 to the negative 6. And then this divided by this, 1.31 or 1.35. Shoot. $1.79. How did they get that? q squared over 2c for d minus b divided by 2 epsilon 0 a. Two ci. Oh, and everything cancels out, so it's just d minus b. Why do they add to the equation though? We know the charge. Didn't we get the charge here? Epsilon 0 a d minus b. The other one would just be epsilon 0 d. It would be d over d. Dang. So if we know that u is going to equal q squared over 2c or c1 is going to be epsilon 0 a over d. So this one's going to be before and after ui is going to be q squared over 2ci. This one's going to be d minus b, this one's going to be d, so we already know what one is. The other is going to be okay, we've got that. Now if I do q squared .0, is it 0.79? And I divide this by still not getting it. D minus b. Hold on. I divided the wrong way. Yeah. Getting 0.92. Yeah, it's 0.79, so something's a little bit wrong. It's because I'm just doing 0.79 and 0.41, I think. Oh, wait. I did it by 7.9, not 7.4. Okay, yeah, I got it. They really want the 9. Well, I got 7.75, so I got 8. Is that going to be close enough? Okay. So at least I know now what they were asking. That's pretty neat. And how much work is done on the slab as it is inserted. Some work done is changing U, right? We found both of the U's. We found the difference. So is it just going to be U final minus initial? Which is 1 point. Oof, that's tiny. Oh, no, they actually found a very regular number. Now I'm not liking this so much. It's just the change in U. Final minus initial. Yeah, it doesn't matter. I'm getting the same thing both times. It's a very small number. What the heck did they even say? This just be yeah. U initial, U final. U initial. U squared over 2C. Epsilon 0A. The area here is 2.45 times 10 to the, I don't know, what is it? Negative third or something? Okay, I'm getting 6.53. Oh, I'm still not entirely right looking. What in the heck? Oh, okay, I got it. 6.1. Yep, there it is. Assume work done is positive, so I have to put it in as a negative. What? I don't get it. Assume work done by the slab is positive, but you have to have a negative number. I guess work is a negative quantity or something. So what we do is Q D over, or Q squared D over C minus Q D minus B over C. And in this case, C equals epsilon 0 A. So instead of, actually it wouldn't really be C, it would just be epsilon 0 A over D. This would be epsilon 0 A over D minus B. See, these are going to be our C's, but because we're dividing by division, we make it a multiply. Just multiply it. That's how that simplifies out. And this one would be sucked in. And that's as simple as how that one goes. And then, here we go. Final one. Why did I do that? Okay, so we're going to have radius inner, radius outer, 37, 47. We want to find the capacitance, and if we look here, we've got one just for this such occasion. C equals 4 pi epsilon 0 A B B minus A. Yep. So this is going to be 4 pi times 8.85 times 10 to the negative 12 over 37 times 47 over 47 minus 37. I'm getting 1.933, and that is millimeters, so I can like e to the negative 4, but it's pico, so that's like negative 6, so negative 2, so it's 0.019. No. 19.3, I went the other way. It would be 19.3. Okay. And then what must the plate area for a parallel plate capacitor with the same separation and capacitance? Okay, parallel plate. C equals epsilon 0 A over D. And in this case, the D is going to be 47 minus 37, which is just equals 10. So I have 10, and the capacitance here is going to be the same, so it's 19.3. So now we're going to multiply this by 10 and divide this by epsilon 0, 19.3 times 10 divided by 8.85 times 10 to the negative 12. I'm getting a very large number. 218. Simple as that. So only one I didn't do is this switch one. I actually still have to work on that, but other than that, that's the whole homework. So that's pretty good. Only one I had some problems with was this slab one. But it makes a little bit of sense. I'll have to ask more about how it works, but it makes sense. There you go.